Right? We go back to your grade 11 circle geometry. Right? We now have triangles inside circles. Okay? So that question requires application of grade 11 circle geometry. Okay? So you've got your C, it says show that C2 is equal to D1. Your C2 is here, and D1 is here. This is D1. Right? So those are the two angles. Right? I'm not sure how you did it, but in my case, first we have got a tangent there. So I'm going to prove that C2 is equal to A4. Then I'll also prove that A4 is equal to D1. Then after that I can conclude this. Right? So it's a bit easy and straightforward. Okay, so here, yes? E4 A4 yes. Yes. That's what I did and use angles. Yeah, it's fine. If you did it that way, it's fine. So E4 is equal to two angles, G1 and E2. Okay? And then you can carry on after that. But in my case, I'm not going to do it that way though, but that's also mathematically correct. So I'm going to say C2 is equal to A4. Okay, they are alternate angles. So AB is parallel to EC. AB is parallel to EC. Then I'll also say here D1 is equal to A4. And that's the tan chord theorem. Okay. Now, since we have the same angle on the right hand side of the two statements, we can therefore conclude that therefore D1. Okay, we'll start with C2 here, so the C2 is equal to D1. Okay, so that's pretty straightforward. Right? Then the next question, it's on similar triangles. Okay? Now, with similar triangles, generally, as I said, I think the day before yesterday or yesterday, the names of the triangles that are similar are named based on corresponding angles. So you just use the given names of the triangles based on the corresponding angles. So here we have got this A here. So we've got ACF, let me highlight it here. So we've got ACF, which is this one. And then we have ADC. Okay, so ADC. So those are the two triangles. Already you can see that there's something common with them. Right? Right? They have an angle which is what? Which is common. Right? This A here and that A, they indicate to us that more probably the angle is the same. So sometimes we have A1 and A2. So in this case here, we have a common angle here. That angle A3 belongs to both triangles. Okay? So I'm going to write here in triangle ACF and triangle ADC. Number one, angle A3 is common. Okay? Then number two, okay, let me do it there. Alright, let me do it there. On the top there. Okay, I've got that. So number one here, angle A3 is common. Then we already proved that C2 is equal to D1. Right? And when you write it, you must write angles that belong to the same triangle on one side. So I'm going to start with C2 because of the name of this triangle. Okay? So this will be C2 will be equal to D1. Then you write here proved in 3.1. Right? We proved that already. Right? Once you have two sets of corresponding angles, don't stress yourself to determine the third pair. The third pair, you just write here. We identify the other angle, it's going to be F1. Okay? So this will be F1 will be equal to angle C, right? Okay, let's see. So this one is going to be C, so it's going to be that one there. I'll call it ACD. Okay? So ACD. Naming the angles is very, very important. Naming them correctly. So this one will be based on sum of angles in a triangle. Once you do that, therefore, triangle ACF is similar to triangle ADC. Write your reason triple A. Okay, so that's what you're supposed to do there. Right? It's not that complicated. Right? Now, this is very important for you to know. If you do a lot of practice, you'll find that in most cases, if you're asked to prove that triangles are similar, the questions which follow after that, they will require you to apply your knowledge of similarity based on ratios of the corresponding sides. So question 3.3 has a connection. This has a connection with that. Okay? We have proved that the two triangles are similar. Then you need to use this now to do question 3.3. But to do 3.3, you also need to take into account the fact that AC was given as being equal to AO. Right, so let's highlight where AC is. So this is AC. Let me do it on the other diagram. Right, so AC, this line here, it's equal to AO. Okay? Now, I can use, because I want to prove lengths here. Because I've got lengths, I can introduce the constant. Okay? So if I introduce the constant, I can, let's say AC, I can call it K. It means AD is going to be equal to 2K. And that means AO is going to be equal to what? To K. Right? I've proved already that these two triangles are similar. Yeah. So I'm going to write the ratios of the corresponding sides. And then from there I can prove this. Okay? It's very easy if you know this. Right? So from here I can write, let me write my ratio. So I've got AC over AD. So AC over AD will be equal to CF over DC. And that should be equal to AF over AC. Okay? Now, this is true because of similar triangles. So those triangles are similar. Sorry, no. Similar triangles. Yes.
Ratio AC over AD. I get that. It's the CF over DC. Where did that come from? Well, how do you know this?
I'm using this. The names. I'm using the names of these two triangles. AC corresponds to AD, CF corresponds to DC, AF corresponds to AC. Okay? Once you have this now,
how did you get that A or is equal to 2K? Or you just use it?
okay, we are told that AC is equal to AO. So I call this 2x. And AD is a diameter because there is a center there. The diameter is twice the radius. Huh?
You're saying the whole length of AD
Is 2x. Because I called AO what? X. Are you following that? Huh? Are you following? Yeah, because to come up with this 4 here, it's gonna come from this 2k. Do you see that? This 4 here is gonna come from that 2k. Okay? Now that I've got my ratios there, if you look here, I've got AD, okay? I've got AD, then I've got 4AF. Now, based on the information that's there, it is much better to, in fact, you have to identify the correct one. So which one can I identify? I've got my AC, I've got my AD, right? Then I've got AF, so I'm gonna take this one, and I'm gonna take that. Okay? Can you look, please? You write all three, but you choose the appropriate for the question. And that will require common sense. Okay? So, I'm going to write here AC over AD is equal to AF over AC. Okay? Alright? Then, we have got this one here. So that will be AC. So if I square, and these two are the same, so my AC is going to be K, that is over AD, which is going to be 2K. Right, okay, let me do it this way. Let me check it right. Right, I first multiply. Okay, let me check if I didn't write it. Let me check if I wrote that correctly. AC over AD. Can you wait, please? I need to check my ratio. AC over AD. Right, I've got that. Then I've got CF over DC. CF over DC. Okay, don't get that, then AC over AC. Alright, so what I'm gonna do is I need to manipulate my ratio. Yeah, I've got AD, so if I swap this, then bring that down. So my AC is K, and this AD is going to be equal to I make that K, so this is K divided by AD, which is 2K, and that's AF. Okay, AF. Okay, so I'll have AF over AC, which is equal to K. Okay. I think the best way for me here is to calculate AF in terms of K. Okay? Is to calculate what? AF in terms of K. And if I do it that way, then it will be much better. So AF, and if I simplify here, I'm going to get a half equal to AF over K. So K is going to be equal to 2AF, which means AF is going to be equal to half. And AF is going to be equal to K over what? 2. Are you following that? Huh? Right? Now, from there now, I'll say DC, sorry, it's AD rather, AD over AF is going to be equal to, so I know that AD is 2K and AF is K over 2. Okay, so I'll get my AD over AF. This will be equal to, now here, when you divide it becomes 2K times 2 over K. So that will give me AD over AF is equal to 4. So AD is going to be equal to 4 AF. Okay, so that's how we should have done it. Okay? Now, the question, it requires some thinking. Okay, it requires some thinking. It's not a direct question. So you have to think, use your knowledge of the constant to try and do it. Now, take note here. Knowing how to use the constant will make your grade 12 geometry very, very simple with regard to this question. Okay, so this is a higher order question. Right? Yes. What's your question? From which part? All right. In the first place, you understand that, right? Then, when you get here, okay. Are we given any dimensions? Not given any dimensions. But we need to prove that AD is equal to 4 times AF. Remember, we have got a number there. How do you come up with that number? Based on the information in the whole question. The only way is to introduce the constant because we are told that AC is equal to AO. So I called it K. So this is K rather. So I called it what? K. So it means AC is equal to K, but AC is equal to AO. So AO is also what? K. But AD, it's a diameter. The diameter is 2 times the radius. Your AO, it's a radius. Right? So to get the diameter, you multiply AO by what? Sorry, by 2. So you get what? 2K. Then, similar triangle. From there, we choose the appropriate ratios. We don't want this one. It's not going to help us. Right? So we choose the first one and the what? And the last one. Then you substitute. But the problem came now is I know what AD is based on my constant. So I substituted it there. Then I realized that I need to find what AF is in terms of K. So substitute there, substitute, simplify, get the what? The length of AF in terms of K. But I also know, by the way, I never told you this. You see this statement here? You work smart when you're doing this question. If you divide both sides by AF, you get AD over AF is equal to what? Is equal to 4. So you also use whatever you're asked to show in a smart way to show it. Are you following what I'm saying? So to get this 4 here, you divide AD by AF, which is what I did here. Then I substitute AD, substitute AF, simplified, and I got my what? My 4. Then I multiply this AF by the 4 to get what I'm supposed to show. I hope you are following. You following? It's making sense. Right? It's a high order question. And you should expect that in your June examination and your final exam too. Alright, let me carry on. I've got 8 minutes, so let me start the next question. Okay, so the first one, we have GFM. So this is GFM. So that's the angle there. And are we told that this is the diameter? No. Okay, so we can't assume that KF is a diameter because we are not told in the question. So we can't assume that it's a diameter. Then, so we've got that angle, then we've got AKM. Okay? LKM, which is that angle there. Okay? What was your answer why they are equal? Corresponding. Right? They are corresponding. So, here you say because they are corresponding angles. Alright. Okay, they are corresponding. It's one mark. You don't have to give a reason. Right? Your reason is this. No need to stake the lines that are parallel. So you don't have to, because they are saying give a reason why. Why are they equal? Because they are corresponding angles. And you know that corresponding angles are what? Are equal. If you want to provide more information, it's fine, but it's just for one mark. Then GH equal to Y. So we have got G here, we have got H, and we are told that LH is equal to GH. So those two are what? Are equal. Okay? Now, can we have one lesson? And then we are also given the dimensions, okay, of MF. So if I want to get the length of GH, okay, I'm going to get LG first. Then I'll divide LG by what? By 2. Okay? Alright? So let me do it very quickly. So in triangle MGF, if I use the proportion theorem, I'm going to have ML over LG is equal to MK over KF. And that should be line parallel to one side of the triangle. Okay? ML is Y. LG, I don't know it. MK is equal to X. And KF is 2X. Right? So what this means is LG is going to be equal to, now we are going to get it in terms of Y. So if I put it there and bring it down here, I'm going to end up getting, okay, these two can cancel out to avoid issues. Okay, I hope you can agree with me that from here, I can swap these two and write this as LG over Y, and then swap those two, I'll get 2 over Y. Okay? If you swap the numerator on the left, you did also on the what? On the right. So this will give us LG equal to 2Y. Okay? But LG is equal to LH plus HG. And these two are equal. Okay? But LH is equal to HG. Therefore, I can have here 2Y is equal to 2HG. So HG is going to be equal to what?
Is it okay?